Swayam Prabha. Digital India. Educated India.
So today's class is on collaborative model for innovation. This is a culmination of all the three aspects of design, technology and innovation. So you'll see this particular sort of development happened as a research project of mine. While I worked in industry for nearly 7 years. Then after industry experience, I joined IIT Delhi as a professor. And then I started my PhD then because I realized that innovation needs a different type of skill set, and innovation was at a very early stages in the country. We didn't see many developments in the country at that time. Even the cars were very few. At that time we only had two brands running in the country. So in that stage we said let us work out a research program where I did PhD in the area of collaborative innovation. So this whole journey I'm going to show you of how we build this collaborative model from real case studies. So the main objective was to enable organizations to generate innovative product ideas. It could be organizations, or it could be students, or it could be non-government organizations. Any of them, if they have to come up with innovative ideas, and these innovative ideas need not necessarily be product ideas. See, for all of you, I'm telling you, this could be communication ideas, it could be animation requirement, it could be interaction ideas, it could be anywhere, but the methodology is the same wherever you take these ideas forward. So here we specifically built this using real case studies. Then we actually took them as sponsored projects with students. And if you take them as sponsored project with students, the industry is partner to this. So when you call it a sponsored project, what happens is the industry pays a large sum of money to the institute so that the professor and the student is part of the team. Okay, so here then only it will be called a real case study. Otherwise the case studies are not real. Okay, so that was done. And then these were live case studies which address the complexities and operational issues related with innovative product idea generation. Because what happens is if you're doing a fictitious classroom project, which is called a mock project, you won't get the complexities as clear as when you do a real project. So when you talk about a real project, the most important aspect of the project is that you need to get an industry partner, which is the toughest stage. And most of the industry partners were ready to come to satisfy their current small issues. They would not come to work on an innovative next generation product using new technology and new materials or new design. They would say, you just redesign my product. So we had to find the right partner to do these projects. We had to form teams both in the industry and at the academia. That is, for example, I have a student, the guide who was me, and some of the colleagues from other departments who were part of the teaming process. And then we had to come up with a product brief. Then the team would develop ideas and then build into concepts. The concepts, come up with multiple 3 concepts. Then these would be refined. And finally, the final concept would again go into the network loop to see whether innovation can happen or not. So this is the total, methodology we followed for the research. In research, it's very critical to have a very strict sort of, methods, because each case study has to follow the same method so that we can actually get them into a particular framework to come up with the model. Then this model will be very effective for everybody. So here we come up with these live case studies. The first case study was the design of a bicycle, next generation bicycle for Hero Cycles. Hero Cycles is the largest manufacturing, bicycle manufacturing company in the country. And, we were very lucky that they agreed to partner with us in this journey. Then the next project was a dual chambered bottle for a beverage company. This company wanted the bottle to be manufactured, which has dual chambers. He wanted to supply masala milk, and the masala liquid should be mixed just before drinking the milk. If it was mixed before, the aroma, the taste will all get ruined. So that is called a dual chambered bottle. The top chamber will have the masala content and the bottom chamber will have the milk, so you can mix. And you want to use it for various other Indian beverages. So you want the bottle, designed for that purpose. The third product was the petrol pump design. Before I joined the IIT Delhi as a professor, I'd worked on petrol pumps, and the competitor came rushing to us and said we would like. So this was a very easy client for us because he knew that we would work on innovation, and this was a company called Midco which wanted to sort of come with an innovative product. And the fourth one was from Hero Motors. Hero Motors was manufacturing a moped called Hero Puck, and they wanted to sell it in the Argentinian market. And they said, we want to really work on the form innovation as well as user convenience innovation for this vehicle. And the last project was from the Godrej Locks division in Bombay. They said that we have a lock product which we would like you to redesign at 50% of the cost. So each one had a challenge. So from these challenges, we started our project. So while we went ahead with our real case studies, we had a student who would work on the project earlier, like we discussed this helmet case study. The student is the full team member. We call him the person who is fully responsible. We had the guide, who was me, who was from the design school, and we had an engineering professor from another department who would be his co-guide, and that was called the team which was at IIT. Then we built a team which was at the company level, where the company would then give their person from marketing, one person from manufacturing, one person from supply chain, and one person from their finance. So that way we had 4 to 5 people from the Hero Cycles company. And in this case, remember I was telling you, all these case studies have to have a particular framework. And what is the framework we used? The framework was called Situation, Actor, and Process, SAP. Learning, Action, and Performance. This is the SAP lab, and this was actually done by my professor, who was my guide. My professor who guided me in my PhD is Professor Sushil. He was from the School of Management in IIT Delhi. So he was my guide, and he came up with this framework to assess case studies. You do a case study, you apply this framework, and you analyze, and you come up with learnings so that you can act on the learnings. After acting on the learnings, you can have your performance, you can make things happen. In fact, we were very lucky. We were at the gate of Hero Cycles, and my God, it was like a highway, because they're manufacturing 24,000 bicycles a day. That's a huge quantity. In a truck, you may get around 200 bicycles. So if you have to manufacture so many, how many trucks have to move in a particular day? And then on top of it, if you have to manufacture so many bicycles, the parts have to come from all over Ludhiana, right? Hero Cycles in Ludhiana. They have to come from various locations. So all these people, vendors, would start supplying material in their trucks. So the main gate of the company was like a huge sort of gateway of trucks going in and trucks going out. That's the type of volume they're manufacturing. And they were having a stiff competition from China. China was supplying bicycles in India at half the price of Hero Cycles. And Hero Cycles was threatened. They were saying that if they start supplying at large quantities like here, what will happen to my business? So they were really concerned, and that was the assignment they gave us, that you design with your innovation. We want a low cost bicycle. You come up with innovative materials, you do whatever, but our cost of the bicycle should be low. So here we are. Then we have to understand the situation. What all Hero Cycles is doing, they outsource a lot of pipe manufacturing, component manufacturing outside. They assemble the bikes in the factory, not capable of producing high quality products. That's very interesting. This information also was given by the CEO. When you weld a frame, what happens? When you weld something, what happens? When you weld pipes together, the stresses develop in the pipes, right? Your pipes are never in one line. So your front wheel and your back wheel in all our cycles are never true. If they are highly true, they'll be the best cycles. You'll be having very little load to bicycle. They'll be phenomenal. You'll see the difference drastically. So here the biggest challenge was getting the pipes in one line and getting your front wheel and the back wheel in one plane in exact one line. And that is the most important test for a bicycle's accuracy and cost. And we were very lucky. The Munjal, who was senior guy, was around 75 to 80 years at that time. He came and gave us this very interesting one-line brief saying that we need to innovate. We need to come up with a bicycle which can beat the Chinese competition, but also have a form factor which is very different from the current cycle. So very we were very inspired by him, because at that age he could give that type of phenomenal direction to the project, whereas all other people from marketing and all were talking about their current problems rather than looking at that. Here the actors are the student, guide and the co-guide. I told you, co-guide is from another discipline. For example, if I'm doing bicycle design, I would take a co-guide from applied mechanics. The professor from applied mechanics was our co-guide in the project. So we have 3 people team. Then the second team was from the company CEO. The top management support is very critical. So here we have the CEO coming in very closely. Head of design, DJ marketing, and head of export division. This is chosen by them. Hero Cycles also exports a lot of bicycles all over the world. And of course, this third team was built after we started the project. And this team included out-of-the-box vendors like Maruti Udyog, who were designing products as a vendor to the car company. We had Caparo vendors who were experts in deep drawing. We had some sheet metal consultants who came from outside, and they were experts in deep drawing, professors from IIT. So this is a new team which was built up after we understood that we can't handle this project without some more additional information coming in. So that was the third team which came up. So we did the data collection, we found out what all is happening, and then we came up with a lot of ideas which are important for us to see whether we can merge all this and come with a cycle idea. And cycles have been very phenomenal in their simplicity and use. So what type of ideas can we come up were the biggest challenge. So we want to solve the pipe structure problems. So the pipes were the biggest problem because the welding was getting stuck. All of you know the bicycles. The weldings were not proper. The welding was taking a lot of time. Then we also looked at the possibility of use of other materials. How many of you have ridden aluminum bicycles, aluminum alloy bicycles? Very good. They're very light, right? What happens when the cycle is light? It moves faster and less effort, right? But the aluminum alloy is so expensive that the cycles generally cost 3 times the regular cycles, 3 to 4 times the regular bicycles, because aluminum is difficult to weld and the alloying, is a special process. The biggest breakthrough came when we did the idea generation for a deep drawn bicycle. How they were manufacturing cars? They're manufacturing cars by sheet metal draw, right? The car body is drawn by large presses. You will see on videos. So when the large presses is pressed, you get a whole part at one go. So can we manufacture bicycles rather than pipe welding? You manufacture by, deep draw process. That was a very big insight, and we'll show you how that insight, went forward. So a lot of ideas came up with, aluminum, die-cast materials, aluminum pipe structures, mild steel structures, riveting the structures together rather than welding, because that was taking a lot of effort. And here finally you come up with your focus cluster. So here you have 3 focus clusters with 3 different types of materials here. This first concept is a sheet metal drawn bicycle. Isn't it interesting? As soon as it becomes sheet metal, what's happening to the handlebar? It's become very long. Because in sheet metal, if you got to get the same stiffness, your length of the fork will have to be increased. Otherwise, it will start wobbling. So this is a very interesting characteristic of a sheet metal, and all this is drawn at one go in a press. So you get a one single frame bicycle. And this single frame bicycle, you can have special alloys to make it very lightweight. Here, for example, you have box pipe frames made up of aluminum. Aluminum box frames are very, lightweight and cost effective in welding, easy to weld. So this was on box frame welding. And here it was again, again a mild steel, structural welding, which was again being used over here. And the sheet metal concept was selected as the best concept because the advantage of using sheet drawn concept was that it would become very cost effective. The prices will drop straight away by 75%. Because what happens in a pipe bicycle is pipes are actually sheet originally. They cut the sheets and they rolled into pipes, and that's how the pipes are manufactured. Pipes are not extruded. Cast iron pipes are extruded. Most of the pipes are sort of rolled and welded. So just imagine if I directly take the sheet and use, my cost will be very low, and because of the manufacturing process of deep drawn, it's very fast process. You get you don't know welding, no cutting, so it will become very cost effective. You can see how the whole frame has been built in one go, and then the further development happened. And then in the same process, we have something called the mock-up models. Remember, I was always talking about mock-up models here. So you build mock-up models of this to understand how the design would work, and from these mock-up models, we built one full-scale mock-up, non-working mock-up, because you need special steels to make a prototype. and it was very difficult to procure those steels at that time, and you needed tooling which will become very, very expensive to do. So this became the option for us to show to the company, and of course the company was very thrilled to see this product because the cost was actually finally 75% of the current cost of material, whatever material they were using. But the biggest challenge here was the tool cost was very high. So they had to invest around 50 lakhs in tooling to produce this bicycle, which will be 25% cheaper. So what did we learn from this journey was the interaction of the first team with the team of experts was iterative in nature. So this interaction with the experts who are doing the sheet metal drawing and all became very iterative, and the concept development happened with experts from the manufacturing sector in sheet metal. The concept detailing stage, one concept was preferred over the other. In all the concepts, why the other concepts were not chosen was because of the focus. The main reason for our journey was that we need to start with the low cost aspect, where all other concepts were not low cost. So we chose the concept which would result in low cost production. So that was the reason. And the main learning was solution to existing design problems may lie in completely new paradigms. What is this new paradigm? Car manufacturing. A car paradigm of deep drawing. And cars are cheap only because of deep drawing and because of the large manufacturing base which they have. And special partners need to be selected. So what is the learning for us for the collaborative team? You to select special partners, like the people who are experts in deep drawing, the people who are professors who are experts in alloying of sheet. So I had to go to Tata Steel and request them to produce this special grade of steel which can be deep drawn and which will be stiff, because your bicycle can't wobble, right? The sheet has to be stiff. Of course, the form factor is there. He made the form which is ribbed so that it will be stiff, but the material also has to have the property. So that was the major, learning in this case study, that you need to really bring experts into the field during your design process. So here, this is the dual chambered bottle. The same journey, lot of ideas were built. After a lot of ideas were built, and each idea was taken from a creative analogy. So the first idea was, if my opening is like the shutter of a camera, there's an opening and closing, right? So if you take inspiration from the shutter, the dual chamber, for example, the top masala can get mixed with the milk by moving a shutter, right? So I take an analogy from a camera to design my dual chambered bottle. So here you have the shutter in this, and you move this lever and the shutter opens, and only when you want to drink the masala milk, you're mixing the masala with the milk. So here we have the second idea was taken from these dispensers, the tubes for ointments, where there is a layer of the silver foil, and you press with the end of your cap the ointments. No, you reverse the cap and you press and you puncture the hole. So this was like a puncturing mechanism. You have a foil here and you have a button. So this content will get in by puncturing the foil. So this is a puncture mechanism, okay, which can't be reused, of course. And the third option was inspired by traditional soda bottles with a ball. So this soda bottle, you press the ball out of its location, it goes and settles somewhere else, and the channel becomes open and you drink. So here, for example, you move this ball and automatically channel opens because the ball is elliptical, and then the channel opens. The top masala liquid will mix with the bottom. So this was a live project. The beverage company was on our back. He wanted a patent for this. When you want a patent for such a product, you have to go and look at your patent thing. We found 500 patents for a dual chambered bottle. And my student went, haywire. He said, sir, how can I make one more, which is good? But that's what the beauty is. Here, for example, we found out that the need was very critical here. The client said that this particular bottle should not be more than 10% more expensive than a regular beverage bottle, like a PET bottle, which is used for Coca-Cola or Thumbs Up. If those bottles are costing you 10 rupees, this should cost you 12 rupees, not more than that. And when you went to the web to see how many patents were there, all those bottles were for different purposes. They didn't have that type of cost and type of aspect. So as soon as that came in, the PET bottle, we talked to the PET manufacturer straight away, and he told us that we are coming with a new material which is 10% cheaper than the current material. So you design with our new material, you'll be able to come down your cost already by 10%, and then you come up with your other designs which can work. So those bottles, you put them together, and finally the whole team decided that they'd like to go ahead with the shutter one, which is more simple and more easy to operate and more cost effective. And then then the actual work started of detailing. So here, how will the shuttle work? So here you have this, the very interesting slope given. Without the slope, what happens is your, sealing is not perfect. So you have these shutters. When this turns in these locations, it is closed, and when these two match, it's open. It's a very simple mechanism. But the biggest challenge here is it should be leak-proof. That's the very challenge. And where did we get the inspiration for leak-proof? Tell me. Have you seen these leak-proof taps, stainless steel taps with a rod? What happens in them? It's just a taper, right? And in that they put a, the brass receptacle. So it goes, because of the taper, it goes and locks. There's no rubber there. So we took that inspiration from that, design, and we use this taper over here. So this is no longer flat. This is tapered like this. So when you lock with the taper, you get very good waterproof, design. So these were designed, and then finally it was, implemented in the bottle. And the bottle, actually was just 15%. It was not 10, of course, 15% more expensive than the current bottle, because this piece, the plastic pieces were extremely low cost. So the bottle had the turn in the middle. So you hold the bottle, turn the whole ring, right? The ring on the top, this ring, and your top content will get mixed to the bottom content, and the dual chamber bottle was ready. So the client was wanting a patent, so we got it patented, and after that we really don't know what happened with the product, but we're hoping that he's manufactured it.